Hey everyone. In this lesson we are going to talk about a couple of types of energy that we encounter all the time, literally all the time. Um, these are in our everyday lives. We don't really talk about them that often, but they are always there and we're always interacting with them. So the first type of energy is called kinetic energy. And you can see it is energy of something that is in motion. So anything that is in motion, anything that's moving, has kinetic energy. So, for example, sports are great examples of kinetic energy. So a baseball bat, when it's being swung by the batter, has kinetic energy. And then as it hits the ball, that kinetic energy is being transferred to the ball, and the ball then has kinetic energy, a lot of the kinetic energy that the bat had. Same thing for kicking a soccer ball, bouncing a basketball. Anything that's in motion has kinetic energy. The other type of energy that is sort of the opposite of kinetic energy is called potential energy. Now this is the energy of something that is at rest or something that's not moving. So in this case, we could say the energy of something that, let's say we pushed a big boulder to the top of a hill, and it was just sitting there, and it wasn't moving, but it has the potential to roll down that hill. And so it has a lot of potential because it's at the top of a hill. If it's at the bottom of a hill, it doesn't really have much potential to roll down a hill, so it doesn't really have much potential energy, even though it's at rest. So let's say, hopefully this will make it a little more clear. So let's say we have this tennis ball. So as I'm bringing it up here, it has potential energy because when I drop it, it has the potential to go down. Now, as I drop it, when it's in motion, it will have kinetic energy. So potential is now, and as it was falling, it had kinetic energy. So this is a little tricky to think about it if this is a new concept. So we're going to do an experiment that will hopefully illustrate it a little better. And in this experiment, we're also going to have the chance to practice the scientific method. Okay, so we just need a few simple things for this experiment. We need a rubber band. This is going to be our source of energy. We also need half of a container of something. So you can use a paper cup, you can use a plastic cup, you can use this plastic yogurt container. You just need to cut it in half, so you might want to get your parents' help with that. And then last, you need a piece of paper. And it's great if it has lines on it. It doesn't have to. But what we're going to put on this piece of paper are some lines. So what we're going to be experimenting with is how much energy is held sort of in a rubber band when we stretch it out. So we've talked about the scientific method in class before. So just as a reminder, there are 6 steps usually that we talk about with the scientific method. The first step 1, is a question. This is a question that we want to ask that we're going to try to figure out the answer to. So the question here is, I'm going to say, I wonder how much energy a rubber band can hold when it's stretched out. And so step 2 then is our hypothesis. This is a guess about how to answer our question. So my hypothesis is that there's more energy in a rubber band when it's stretched out, and I should say there's more potential energy in a rubber band when it's stretched out further than when it's not stretched out much. And so now comes to the fun part. This is step 3, experiment. So to conduct this experiment, we're going to, or this is at least what I did, you can do some variation of this. You're going to put something like this on your paper. So I have start down here at the bottom, and I have different lines for how far away from start they are. So how this is going to go, we're going to lay this on the table on a flat surface, and then we're going to put this at start, and then we're going to basically shoot it with a rubber band and see how far it goes. So step 4 is data, collect data. So that's what we're going to do when we do the experiment. Step 5 is analyze the data. So figure out what is the data telling us. And then step 6 is kind of report the data. Did the data confirm our hypothesis? Did it say that our hypothesis is correct? Did it support our hypothesis? Or did it refute our hypothesis? Refute is what the word that scientists use when the data doesn't agree with the hypothesis. So let's get to it, and I'll show you how that's set up. So we have a rubber band here, and we're all familiar with these, I think. So when we pull it back, when we stretch it out, it's at rest, right? So it has potential energy, right? It's ready to do something. It's ready to fly through the air when we release it, or it's ready to strike something and transfer that energy. And then when it's actually moving, then it has kinetic energy because it's in motion. So we are going to see if there's a relationship between how far we pull it back and how much energy it has. All right, so here's how that's going to work. Let's lay out our playing field, as it were. So this is our start line. So we are going to put our yogurt container or whatever you are using at the start line there, just right there. And so the opening is going to be right there. And we're also going to decide how we are going to conduct this experiment. So I'm going to decide, I want to do two different types of pulls, two different lengths of pulling it back. So I'm going to say, I'm going to pull it back just past my knuckle there, right here, and for one length, and then for the other length, I'm going to pull it back all the way to my wrist. Okay? And I'm going to do each one of these 3 times because we always want to have more data points. So let's get to it. So first one, I'm just going to pull it back right there, and you can decide whatever you want to do as far as how far you want to pull it back. And then I'm just going to shoot it right in and see how far it went. So it went almost to 1, at least on this side. So we just want to make sure that that is normal. So we want to do it a couple more times. Okay, almost to 1 again, so that looks good. It's a good sign. And then we'll do it one more time. Yeah, so if we pull it back to about where my knuckle is, it goes to almost 1 down our playing field that we made up. All right, so now I'm going to pull it back to right about where my wrist is and see how far it goes with that. All right, that went a lot farther. So about to 3 there. So again, we want to do it a couple more times just to make sure that we're getting consistent results. Yep, right about to 3 again, at least on one side. This side didn't quite make it. At least it's past 2. Okay, we're going to do it one more time. And that one went past 3, almost to 4. So a little bit of variation. Maybe I pulled it back a little further on some of them. Hard to say without being too precise. But we definitely saw that the more you pull it back, the more potential energy is, and the more kinetic energy there is also. Okay, so we were just conducting an experiment involving potential and kinetic energy. So, to review, we asked a question, and our question involved the rubber band, right? It was, I wonder how much energy is being held in a rubber band, or whatever you came up with. And then we formed our hypothesis, step 2, and the hypothesis that I think I said was something like, the further I pull back the rubber band, the more energy it will have in it. And then we conducted the experiment, right? So we had our playing field, and we fired the rubber band at the container, whatever you were using. For me, it was half of a yogurt container. And we saw how far down the field the container went when it was shot with the rubber band being pulled back different lengths. And so it had different amounts of potential energy in it, and then different amounts of kinetic energy once it was let go. So then we had our data. We saw that when I pulled it back to about where my knuckle is, it went to about 1 in this field. And then when I pulled it back to my wrist, and there was more potential energy in it that created more kinetic energy when it was released, and it went all the way to 3. And so then if we were doing this full scientific method, we would write about that and say how our data supported our hypothesis or didn't support our hypothesis. And really, one of the great things about science is it's okay if it doesn't support our hypothesis, because we learned something and we discovered something as we conducted that experiment. And in our case, an experiment with potential and kinetic energy. So I hope that was a fun experiment for you, and I hope it helped to illustrate the concepts of potential and kinetic energy a little better. All right, thanks for listening, thanks for watching, and I will see you next time.